Writing the inverse and graphing log functions. Before we start, let's look at the couple of things that we need to be careful about. If f of x is equal to b to the power of x for all real values of x, where b is greater than 0 and b is not equal to 0, then f inverse of x is equal to log x to the power to the base of b. So this is how we define the inverse of a function. Also, if this is from fx equal to b to the power of x, that means from exponential to log, and from log back to exponential, because they are inverse to each other. If g of x is equal to log x to the base of b for all positive values of x, be careful with all positive values of x, where b is greater than 0 and b is not equal to 1, then g inverse of x is equal to b to the power of x. Just be careful about these two results. Let's talk about these examples where you need to find the inverse of each given functions. So we know f of x is equal to 5 to the power of 2x plus 4. To find the inverse, first we need to make sure that of course f of x is y and the other side is 5 to the power of 2x plus 1 plus 4. So we need to switch x to y and y to x, so the y becomes x and x becomes y, so x is equal to 5 to the power of 2y plus 4. Just move the 4 to the left side and you get this result right here, and apply after you get x minus 4 equal to 5 to the power of 2x, and we know how to change an exponential form into a logarithmic form. We did that before, few examples. So you can just put that this 2y will be equal to log, basically we are applying log on both sides, then you get 2y is equal to log x minus 4 to the base of 5. Now divide both sides by 2, which is y equal to 1/2 log x minus 4 to the base of 5. To make it final, just make sure you use the right notation for inverse, which is f inverse of x equal to 1/2 log x minus 4 to the base of 5, and that is the final answer. Second one, 3 times 2 to the power of x plus 1. This is an exponential function. We are going to write the inverse of this one, which is going to be a log function. Replace y by x, x by y, and you get this result. X is equal to 3 times 2 to the power of y plus 1. Multiply 1/3 both sides, which is x over 3 equal to 2 times y to the power of 2 to the power of y plus 1. Sorry. Then y plus 1. Apply log on both sides. You get y plus 1 is equal to log x over 3 to the base of 2. Subtract 1 from both sides. You get the final answer, and use the right notation for the inverse, which is f inverse x is equal to log x over 3 to the base of 2 minus 1. Number 3. F of x is equal to log x minus 2 to the base of 4. Replace y by x, x by y. X is equal to log y minus 2 to the base of 4. Then y minus 2 is equal to 4 to the power of x. And here the difference between the first two and the last two is the first two examples are log exponential equations to log, and here these two are log to exponential. So we know how to convert a log equation into an exponential, so that is why y minus 2 is equal to 4 to the power of x. Then move the 2 to the other side. The answer is y is equal to 4 to the power of x plus 2, and use the right notation, which is f inverse x equal to 4 to the power of x plus 2. Same thing here, but the only difference between the number 3 and 4 is this is a natural logarithm. You know the base is e. So replace y by x, x by y. You get x is equal to natural log of 6y plus 1, or 1 subtract from both sides. X minus 1 is equal to natural log of 6y or 6y is equal to, because the base is e, so e to the power of x minus 1, or y is equal to 1/6 times e to the power of x minus 1, or f inverse of x is equal to 1/6 times e to the power of x minus 1 is going to be the final answer.